Hi, I'm McGregor Gaines,
My name is Donald Young.
and we are here at National Reso-Phonic Guitars in San Luis Obispo, California.
What happens here?
And this is where the home of the National Resonator guitar lives.
Right here, what we're going to do is we've got our spinning lathe, and this is where we make our metal resonators. This is just like they would have done it in 1929, where we are spinning thin aluminum metal over a mandrel, over a shape that will turn it into the resonator cone, the speaker cone that goes in our guitars. And what we have here is our actually a rebuilt 1939 Graybow spinning lathe. This is old technology. It is a hand process, and we take great pride in making fine resonators for our instruments, also for old instruments that are out there in the world and other builders too. So I'll commence and show you how we do it. We blank out aluminum. This is a special alloy that we use that is chosen for its specific tonal characteristics. Starts out like a piece like this. We have a small die where we do this half round little form. It's a two-part situation, so I'll be showing you how we spin the second part of the resonator, which is the main part of the cone. Place it here on the spinning mandrel. We bring over the center, lock it down. I don't see my spinning oil, I'm sorry. Where is my spinning oil? Ah, here it is. This is a proprietary secret, but this is what we use olive oil because it's so. Well, it's not poison. You can eat it. So, I'm going to turn the machine on. You can see that the machine is spinning at a certain preset RPM. I'll apply our special spinning lubricant. Number one, I'm going to get our main spinning tool. This is all tooling that we make ourselves. Different shapes for different parts of the resonator, and I don't know what's going to be the best angle for you, maybe just right there, but I'm going to come in. This is a hand process. So you can see how we have formed it so far. Now I'm going to trim it. This, with a cutting tool, I'll trim the edge here. That's sharp. That'll cut you. Wipe it off, get the oil off it. Take away the scrap, and we have a completed resonator cone, almost complete. We do a secondary embossing, which will add these little embossed ribs that help with the structural integrity of the resonator. I think I got one here somewhere. So ultimately, after the second stamping operation, you'll see it with the embossed ribs. And that is the heart of the national guitar.
What we have here is a very, very recent innovation designed by our general manager here and engineering expert Eric Smith, along with Jason Workman here. We have wanted to incorporate a more modern finishing and curing technique of using a clear type of finish which incorporates a UV sensitive vehicle, which is essentially a photo initiator in the clear paint product. And what this allows the finish to do is be cured at a very rapid rate instead of using another type of chemical catalyzation process. This actually is cured with the exposure to ultraviolet light, and it's a very high powered light that is being used. Normally this has been installed in, let's say, a booth with multiple lamps in the booth exposing the component to a high rate of heat as well as light exposure. And one of the frailties of using multiple lamps is that the excessive heat, which causes a problem in itself with delaminations and just overheating the part itself, can potentially be destructive. So Eric had conceived of the idea to incorporate a robotic arm using just one single lamp, which is a more efficient use of the light itself by just reducing it down to one lamp, and in conjunction with the part rotating, the robotic arm is able to mimic a manual operation that would be incorporated by somebody holding the lamp and moving it around. So this is an animated process here that we've just developed. So what we're going to do here is give you an example of using some of our sheet brass, which is an 032, about a 32nd of an inch thick, and cut out some cover plates. And what is right behind me is what's called a water jet. And it's a high intensity stream of water that's coming out at about 55,000 pounds pressure at a very high rate of speed, about Mach 2. So it's an extremely intense stream of water mixed with an abrasive, and this actually is able to pierce and cut out our sheet metal as well as steel and stainless steel up to 3 inches thick. And we use this machine for making our fixtures and as well as all sorts of different cutting out processes. So this is a very innovative machine that we have here, and it has really served us in numerous ways. It's incredible. What we tend to find stereotypically with the National is that everybody connects this instrument with the blues, at least acoustic blues. And that wasn't until quite a few years later, actually almost a decade or more later, did the National come into the use with blues artists. So really the early inception of this instrument was more relating to early jazz, you know, dance hall bands. This instrument was really made to be heard. In the early days, in the late 20s, early 30s, this was before microphones and electric amplification. And so if you can imagine, as I know my parents coming out of that era, you know, the big thing was going to the dance halls, going to dances and listening to live bands playing. And part of that factor, getting out there above the crowd, was actually to have instruments that could project enough to get over the noise in the room. And just like with singers of those days, they really had to be able to belt it out.
Basically, the national guitar, or the Reso-Phonic guitar, was invented by the Dopiera brothers in 1925, 1926, Los Angeles, California, and it was their quest to make a louder instrument. And of course, a Reso-Phonic guitar is a mechanically amplified instrument, and they perfected it and brought it out onto the market in 1926. And of course, it was, you know, high-tech 1920s. Everybody wanted one. And the Reso-Phonic instrument, being mechanically amplified, is kind of the link between acoustic and electric guitars. For about a 10-year period in the late 20s, early 30s, it reigned king. What we use basically in our neck manufacturing is, the material is walnut, mahogany, maple. For the fretboards would be ebony or Indian rosewood. Big chunk of walnut here that will be cut into blank and machined into, as you can see what McGregor's holding here, is a finished neck blank after the machining process. From this point, the fretboard will be glued on, and it will be hand-shaped and hand-sanded to the needs of our customers, guitarists. We can make necks many different ways for people's different tastes. As we say, we can make it fit your hand. We have American black walnut here that we'll be making. This will all be made into necks, and as you can see, McGregor has an example of one of our machine necks. This is after our machining process. A nice piece of black walnut, and engraved actually on our machinery here, so that's one of our Model D necks, identifiable by the headstock logo there.
What we have here is a setup that would be referred to as a progressive fixture, where we have the ability to load the tooling or fixturing with a neck blank, and actually in one cycle time get a completed neck off of that fixture in one cycle time, where it lends itself very nicely for a smaller company like ourselves to change out a program and actually load another neck blank and create another neck pattern if we so desire in a very short period of time. what we have here is the ability to have a virtually completed neck carved on the machine in approximately 13 minutes, which when Don and I first started doing this would take minimum 4.5 to 5 hours by hand to make this part. Now we have something that's very precision made, very consistent in nature, and just a real high quality component right off the machine. And just to show the ease in which we can actually assemble these, I'll show you how quickly, with all this very nice machining, basically we have a snap together type of neck. I'll just do a dry run showing you how easy it is to put the neck stick in, which runs through the body. That fits in. We have our truss rod, a double acting truss rod. It slips right into place. I've already put the index pins into place, and now we have a completed fretboard that essentially lines up with those pins, and without the glue, I've just put this entire neck together in just a matter of seconds. We're looking at another process here using another one of our CNC machines. Now this is a setup where we're doing multiple necks on one fixture, showing that we do carves in series as well. This is a group of ukulele necks that we're seeing here. We've now entered the wood body department, where we build all of our wooden resonator guitars. And we're going to go through a series of step-by-step processes here just to show you what that experience is like in here with the different parts.
These are our automated side benders here, and this is actually the first stage here where we put the waistband in. And what's going on here is that this is heated the shape we want to bend, and the steel on the back side is a constant pressure on the outside of the bend, so it keeps the wood from blowing out or cracking, and it's moving at a controlled rate to also help minimize cracking and blowout. And I would size them, get them set in the mold, and I'd make marks. I've already done that here in this case, but they would come out, make my marks here and here, so I know exactly where to make my cuts. Go to the bandsaw, cut those out. Spreads the sides out and gets them exactly where they're going to be. I'll check my lines, make sure they're where I need them to be, and then I'll do the glue. This is going to be the last check before I glue everything up. What's that? Well, no, just hang out. set our scale length. I'll line that up and use a brad nail to kind of anchor the body. Get it centered on the seams. Same thing on this end, just making sure it's centered.
World War II came, and of course, you couldn't get materials. So National, and as many companies, they had to shut down and join the war effort to lick the Axis forces. And you couldn't get metal to make resonators, you couldn't get metal to make guitars, wood was all appropriated to something else. So National made model airplanes through the duration of the war for the gunnery schools of the Allied forces. Then after the war, they went back, 46, 47, started making guitars again. But the Reso-Phonic guitar had fallen from favor. The electrics were coming in. The technology that had developed during World War II electronically had helped advance electric guitars. So they were like taking B-17 parts and wiring it up, and it's like, this sounds cool, you know. And thusly, the electric guitar, post-World War II, started to become popular, reign king, and the Reso-Phonics disappeared. Relegated to pawn shops, to the garbage heap, and people's closets.
Amazing. So then, fast forward to whenever you guys got into it, which was what, in the 80s, 70s?
Right, right. Actually, National did go through some morphing, let's say, through other employees buying into the company. National kind of merged with, let's say, the name Valco, an airline, and there's a number of old brand names that were associated with National. And National did continue to, let's say, improvise and, let's say, try to stay with the trends in the electric market, and they made a lot of very interesting designs that were very innovative and also very ahead of their times as well, using a variety of materials, plastics, acrylics, and very, very kind of leading edge technology for that time. And I think National has a history of being very innovative, very creative with their approach to the instruments that we are talking about right now. And unfortunately, by the mid-60s, they had struggled to maintain some part of the market and actually outpriced themselves out of the market by always experimenting with some of these more expensive materials, and never really quite regained the kind of notoriety of their earlier Nationals. And so by, I think, about 1965, that was the end of National.
They did have some stuff made in Japan. The people that owned the National at that point did, in the late 60s, have some export guitars made in Japan, which are quite common, and they do surface, but no Reso-Phonic instruments. Actually, I think they did do one Reso-Phonic instrument, that Repro thing, which was a sort of an early Asian attempt at a Reso-Phonic guitar, and it didn't last too long. So then, boom, disappeared.
in the area where our metal body guitar bodies are constructed. And this is where all the action is as far as soldering and grinding and actually building the bodies. So we'll see some of that right now. Essentially, we're building a string-driven speaker cabinet. This is a very rigid type of body construction that applies very similar construction techniques to a speaker cabinet, because essentially we want the resonator to drive the sound.
The resonator is the soundboard instead of making like
Exactly.
an acoustic guitar, which you have fine tone woods and the vibration and the string, this and that, the bracing. But resonator guitar, the resonator is the soundboard. It is the heart of the instrument, and it is unique to the Reso-Phonic guitar, to the National. Structurally strong, but gotta look good at the end too. That's right. Oh, tremendous amount of handwork done here. And the people that we have working here, I mean, this is what we demand of them, and then what they have in their natural ability or are able to be trained to build the components, to put them together, and thusly to make the completed instrument. What we see here is Jim working on the assembly of one of our tricone guitars. This was the original system that was designed by John Dopierre in 1925, 1926. And as you can see, there are 3 small resonating diaphragms. These are done in the spin forming that we showed you earlier. But instead of 1 resonator, it is 3. So you have 2 on the bass side, 1 on the treble side. They are linked together by a cast aluminum T-bridge. And of course, on this saddle piece, this is where the strings will come across and be notched into the saddle piece. Thusly, the vibration of the strings will be amplified by the metal speaker cones, the resonators. And this is one of our steel bodies here that has the prismatic Duco finish. We also do this in, made of brass and brightly nickel plated, engraved. But the tricone, the national tricone, this is essentially where it started in the beginning. Jim has got the neck fit to the body, all the angles right, everything correct. And now he's getting ready to install the tuning machines. Once that is done, he will get strings on it. It will sit without the cover plate for 24 to 48 hours and get used to being a guitar. After that, once everything is checked out, we'll put the cover plate on it, and it will be checked once again, deemed ready for shipping, and will go out to happy customers somewhere in the world. We've estimated it's usually 7 hours, 5 minutes to make a guitar from scratch to finish. And that, of course, is usually over like a 4 to 6 week period of all the components coming through. We are trying to reduce that number, and we are successfully doing that.
Yeah, often the last person that handles it writes his name in it. There's names all through the guitars. There are names on the neck and names in the bodies, and they go through all the different departments, and often people will sign them. Sometimes they'll write messages in them.
That's great. Hopefully good messages.
Whether you make a guitar out of metal, whether it's steel or brass or nickel or wood, everything that you put the resonator in, the material of the body is going to flavor the sound. So with our wood bodies, we get this very rich, warm, deep sound. We'll play bottleneck here. What you see Mark doing here, this is setting up the guitar. Now, it's not merely just filing some grooves in a piece of wood. I mean, this is the bridge. This is where the transfer point of the energy of the string comes to the resonator. As you can see, this is like the resonator that we spun earlier on the spinning lathe. This is the standard 9.5-inch diameter biscuit. They call it a biscuit resonator that was, came out in 1929, 1930. And, what Mark's doing here is making a groove that will, what? Don't know the word.
Minimizes the contact, it concentrates the contact of the bridge to the string in a small concentrated point for tone. You can deaden the string. If the string comes along, wraps around, you'll deaden it.
It all does take time in order to accomplish these things, and so there's a lot of room for experimentation, and we're constantly seeing how we can evolve the tone of the instrument as well. There's a lot of unique styles of guitars out there, and so much of it is about comfort and certain type of voicing that an individual might care to hear.
Future of National, again, John Dopera, the inventor of the Reso-Phonic guitar as we know it today, said to me, 1988, that the Reso-Phonic system, or the Reso-Phonic guitar's system, has barely been scratched. So there's lots of room for individuals to come now and into the future to take this to new places.
Some of the people that are playing our instruments are Taj Mahal,
Mark Knopfler,
Andy York of John Mellencamp,
Joe Perry, Aerosmith.
Bob Dylan.
I think he bought one for his son, but Bob probably plays it too. I don't know. Bonnie Raitt played one for a while, but then she said it was too heavy, so she sent it back.
You guys want a break for lunch or something?
Seal.
Yeah, Bob Brosman, of course, Catfish Keith, Joe Perry, no, I said Joe Perry, Joe Price.
Chris Whitley.
Chris Whitley, who is the late Chris Whitley.
John Hammond.
That's right. John Hammond, yeah. Tampa Red.
Well,
He's gone, yeah, but Diamond Joe Green.
Diamond Jim Green.
Diamond Jim Green is about this big. It's like I can twist your head off, you know.
Let's see. John Mooney.
Frank Corso.
Dowling?
Mike Dowling.
Mike Dowling, yeah, Mike Dowling. Who's the guy in Minneapolis on the radio show, the Pray Home Companion? Pat Donahue. Yeah, Pat Donahue. Keb Moe.
David Holt.
David Holt. Geez, the list goes on and on.